In this video, I am going to explain question number 5, 6, 7 and 8 from Triangles chapter, class 9 Triangles chapter. Okay, exercise 7.1 from NCERT textbook, question number 5, 6, 7 and 8. Okay, now let us see the first question, fifth question now. The question says line L is a bisector of angle A. I have not written the question fully here. You will have your textbook. Okay, I have just written here the given part. Let L be the bisector of an angle A. So we have a line L which is the bisector of angle A. So I have written here line L bisects angle A. And B is any point on L. So B is any point, this is B. B is any point on the line L. Okay, and they also say that BP and BQ are perpendiculars from B to the arms of A. This is angle A, the arms are, these are the two arms of angle A. Okay, so BP and BQ are perpendiculars to the arms of angle A. So in short, I have written here as BP perpendicular to AP and BQ perpendicular to AQ. BP perpendicular to AP, BQ perpendicular to AQ. So I have got it written in short in given part. Given part we don't have to write the full sentence. If we write it in short, that is sufficient. Okay, so symbolically I have represented that BP is perpendicular to AP and BQ is perpendicular to AQ. Now we have to prove that you can see two triangles in the figure, right? One is this one and the other one is this one. Now we have to prove that those two triangles are congruent to each other, and we also have to prove that BP is equal to BQ. Okay, so moving on to the proof. Consider triangles. We are going to prove that the triangles ABP and triangle AQB are congruent. So the same two triangles we will take into consideration. Okay, the triangles which we are going to prove as congruent, we are going to take those two triangles into consideration. Okay, now angle BQA is equal to angle BPA is equal to 90 degree. This is given, right? What is given actually? What is given? It is given that BP is perpendicular to AP. So it is 90, the angle between the two lines is 90 degree. Same way BQ is perpendicular to AQ. So the angle there also is 90 degree. So that is the given information, right? So that I have used it here. Fine. And then angle QAB is equal to angle PAB. Why? L bisects angle A. L bisects angle A. That is, this angle is equal to this angle. It is given in the question that L divides angle A. So these two angles are equal. Fine. Now AB is equal to BA. This side is common for both the triangles. If you notice, this side AB, that is the line L. It is a part of the line L, line segment L. This is common for both the triangles. AB is common for both the triangles, right? So I have written here AB is equal to BA common. Now I have got three pairs of information to prove that the triangles are congruent. Fine. Now I will say that triangle APB is congruent to triangle AQB. Now I have to write the congruence rule, right? What is the congruence rule? What have we used? Angle, side. two angles I have used and one random side I have used to prove that the two triangles are congruent. So AAS congruence rule. Now that both the triangles are congruent, their corresponding parts are equal. That is, I can say that BQ is equal to BP. Right? I can say that BQ is equal to BP. That is what I am asked to prove here in the second part. BP is equal to BQ. What is the reason for that? Reason is very important in geometry. I told you CPCT is corresponding parts of congruent triangles. Corresponding parts of congruent triangles. So according to that, I have proved the first part and the second part. By AAS congruence, I have proved the first part, and from that it implies that BP is equal to BQ, that is by CPCT. Hope you understood this solution. Moving on to the sixth question. The question says AC is equal to AE. Okay. AC is equal to AE. AC is equal to AE. And AB is equal to AD. AB is equal to AD. AC is equal to AE and AB is equal to AD. This is the information given that I have written it given. Now angle BAD. Angle BAD, that is this angle, is equal to angle EAC. EAC. That is this angle. Okay. This is the given information. Now I have to prove that BC is equal to DE. That is BC is equal to DE. This is what I have to prove. Okay. Now for that we will take two triangles into consideration. Now which two triangles should I take into consideration? Just see which two triangles I should take it into consideration. Triangle ABC and triangle ADE. Consider triangle ABC and triangle ADE. Okay, ADE. So these are the two triangles that I am going to take into consideration. Now if you can see, the triangles are like this. This is ABC. Right? And ADE is like this. ADE. Fine? Okay. Now, how am I going to prove that those two triangles are congruent to each other? Fine? Only with the given information. So, whatever they have given, that only I have to utilize to solve my problem. Right? So, I will take this equivalence of angle into consideration. Angle BAD is equal to angle EAC. That is angle BAD and angle EAC is given. Right? They are equal. It is given. So now I am going to add this part, this angle on both sides. That is, I am going to add equal angle on both sides of this equation. Okay. So angle BAD plus angle DAC is equal to angle EAC plus angle DAC. Fine? Okay. Now that I have added BAD and DAC, this will become BAC, and since I have added DAC to EAC, my angle will become EAD. Okay. So these two angles are equal now. Then side AB is equal to side AD. This is given. Side AB from triangle ABC, that is side AB from this triangle is equal to side AD in this triangle. It is given. And then side AC is equal to side AE. That is also given. Side AC from this triangle is equal to side AE from this triangle. That is also given in the question. And the angle which we have taken into consideration from both the triangles is angle A. Right? So now both the triangles are congruent. Both the triangles are congruent. Triangle ABC is congruent to triangle ADE. What is the reason? Reason, side, angle, side. Right? So, SAS congruence rule. It is not enough if you prove it is congruent. You have to write by which congruence rule you have proved it. So, SAS congruence rule is used in this solution for solving it. Okay. Now, after this, since both the triangles are congruent to each other, obviously their third side will be equal to each other. That is, BC is equal to DE by CP CT. This is what we were asked to prove, right? BC is equal to DE, that is by CPCT. That is what we were told to prove. Okay, let us just have a recap of this solution. Once again, they had given me that AB is equal to AD and AC is equal to AE, and they had also given that BAD, that is angle BAD is equal to angle EAC. Okay, and then the triangles taken into consideration are ABC and ADE to prove. Okay, and then the equal angle. This angle was added on to both sides of BAD and angle EAC. Okay, so we got that angle A separately to represent. I have drawn the two triangles here. So angle A from both the triangles became equal. Okay, and it is given that AB is equal to AD and AC is equal to AE. It is given in the question. So by SAS congruence rule, both the triangles are congruent to each other. Fine. Now because of that, since both the triangles are congruent, their corresponding paths also will be equal. So BC is equal to DE, and that is what I am asked to prove here. Okay. Hope the solution is clear to you. Question number 7. This question says AB is a line segment and P is its midpoint. AB is a line segment and P is its midpoint. So I have written P is midpoint of line AB. D is a point on side AB such that it is actually D and E. D and E are points on the side of AB such that, on the same side of AB such that angle BAD is equal to angle ABE. Okay. Then angle EPA is equal to angle DPB. This is the given information. Okay. I have to prove that triangle DAP is congruent to triangle EBP. Fine. And then I also should prove that AD is equal to BE. Okay. Now let us see the proof. Now considering the same two triangles which should be proved that they are congruent, that is DAP and EPB. Okay. The first thing what I am going to do is I am going to take this equation into consideration, that is angle EPA is equal to angle DPB and add equal angle, this angle, equal angle on both sides, that is plus EPD, this side also angle plus EPD. Okay. Now, when I add these two, EPA and EPD, okay, the angle becomes DPA. Okay. Similarly, here the angle becomes this one plus this, it becomes EPB, angle EPB. Okay. Now, after this, it is given that angle, this information I am going to take into consideration, angle BAD is equal to angle ABE. That is, angle BAD is equal to angle ABE. Okay. Now, I have got two informations, two angles, right? I need one more information to prove that the two triangles are congruent. Now, which information can I take? Now, though it doesn't look that it is the midpoint, since I have drawn, it's a freehand drawing actually. So, you have to draw it with pencil and scale. AP is equal to PB. AP is equal to PB. Now, how do I say that AP and PB are equal? Because in the question, it is given that P is the midpoint of AB. P is the midpoint of AB. So, obviously, AP is equal to PB. Okay. Now, which are the three informations taken into consideration? Angle, side, angle. Angle, side, angle. Right? So, both the triangles are congruent. Which two triangles? DAP and EPB. Triangle DAP is congruent to triangle EPB. What is the angle? Side, angle. Okay. So, angle, side, angle, congruence rule. Both the triangles are congruent to each other. Fine. Now, for the first part is proved now. Right. Now, I need to prove the second part. That is AD from triangle DAP is equal to BE, that is BE from triangle EPB. Okay. I can easily say that they are equal because they are corresponding parts of congruent triangles. Okay. So, I can write that AD is equal to BE by CPCT. This implies that AD is equal to BE by CPCT. Okay. Hope this is clear to you all. We'll move on to the next question. Moving on to the last question of the exercise. The question says, in right triangle ABC, ABC is a right triangle, right angled at C. So, this angle is right angle, that is 90 degree. Angle C is 90 degree. That is why I have written here angle C 90 degree. M is the midpoint of the hypotenuse AB. You all know what is hypotenuse? The side opposite to angle 90 degree is hypotenuse. Okay. So, M is the midpoint of side AB. It means that MB is equal to MA. Okay. Also, they have given C is joined to M. C is joined to M and produced to point D such that DM is equal to CM. DM is equal to CM. Point D is joined to B. Point D is joined to B. Okay. We have to prove that triangle AMC is congruent to BMD. That is AMC is congruent to BMD. Fine. And then angle DBC, this one, that is 90 degree. And then we have to prove that triangle DBC is congruent to triangle ACB. Okay. Also CMS half of AB. All these four things we have to prove in this question. Okay. We'll do one by one. Now, considering the first part, the same two triangles to be taken into consideration. So consider triangle AMC and triangle BMD. That is this triangle and this triangle. Okay. When you consider those two triangles, it is given that BM is equal to AM, because M is the midpoint of AB. Because since M is the midpoint of AB, AM is equal to BM. Then it is also given that DM is equal to CM. This is given. Okay. DM is equal to CM. We can say that angle BMD is equal to angle CMA. That is, this angle is equal to this angle. Hope you all know what is the reason. They are vertically opposite angles. So they are vertically opposite angles. Vertically opposite angles are equal always, right? So since they are vertically opposite angles, they are equal. Now, side, angle, side. Side, angle, side is taken into consideration from both the triangles. So triangle AMC is congruent to triangle BMD by SAS congruence rule. Okay. Since these two triangles are congruent to each other, now I can conclude that this angle is equal to this angle. Fine. That is, angle MBD is equal to angle MAC. CPCT. Right? I can also conclude that AC is equal to DB. This is also CPCT. AC is equal to DB. That also CPCT. Right? Now, when you look at this, MBD is equal to MAC. That is, this angle is equal to this angle. They are alternate angles, right? Right? They are on two sides of the same line segment, right? So since the alternate angles are equal, since alternate angles are equal, DB is parallel to AC, right? Since these two angles, that is, they are on the on the alternate sides of the same line, so they are alternate and they are equal due to CPCT. That is from here, okay. That is from the first part of the proof. So the lines DB and AC are parallel to each other, okay. In that case, since DB is parallel to AC, line BC will become the transversal, implies BC is the transversal, right? So since BC is transversal, angle DBC plus angle ACB is equal to 180 degree. Reason being, co-interior angles. Co-interior angles. If the lines are parallel, the co-interior angles, when you add, it should be 180 degree, right? That is how we have learned. Two parallel lines never meet, right? And the two co-interior angles, when you add, you should get 180 degree. That is the rule for parallel lines, right? Now in this we know what is ACB. ACB is 90 degree. So DBC plus 90 is equal to 180. So angle DBC is equal to 180 minus 90, that is 90 degree. So we have proved the first part, that is triangle AMC is congruent to triangle BMD. We have proved that angle DBC is a right angle, that is it is 90 degree. Okay. Now I need some more space here, so I am going to remove this given and to prove part. Okay. Now the third part, we are asked to prove that triangle DBC is congruent to triangle ACB. Okay, so I have drawn it as two different triangles here. Now we can say that angle DBC is equal to angle ACB is equal to 90 degree. Right? Angle ACB is 90, it is given, and angle DBC is 90, that we have proved it here. Okay? Then DB is equal to AC. DB is equal to AC, that we have proved it in the first part. So I can write here from 1. Okay. And if you see, BC is common for both the triangles. This line is common for both the triangles. So BC is equal to CA, that is common. So now both the triangles are, that is DBC is congruent to triangle ACB. What is the congruence rule that is used here? Side, angle, side. So by SAS congruence rule, both the triangles are congruent to each other. Okay. This implies that DC is equal to AB. CPCT. DC is equal to AB. CPCT. Okay. Now half of DC will be equal to half of AB. Yes. DC is equal to AB. So their half on both sides, when you multiply by 1 by 2, they will be equal, right? Half of DC will be equal to half of AB. What is half of DC? What is half of DC? CM. Right? Why CM is half of DC? Because CM is equal to DM, it is given. Right? So this is equal to half AB. So the fourth part also we have proved. Okay? Hope the solution is clear to you all. Thank you for watching. The next exercise will be explained in the next video.